Okay, a blissful morning to you, my wonderful learners. You recall that the last time we met, we have talked about we have talked about approximation to all numbers to nearest tens, nearest hundred, and nearest thousand. So this morning we want to look at approximation in the light of decimal numbers. Approximation of decimal numbers. Okay, approximation of decimal numbers. So first and foremost, before we can talk about approximation of decimal numbers, let's talk about what really decimal numbers are. What are decimal numbers? Decimal numbers are numbers that have points in between. They are numbers that have points in between. The number before the decimal part is your whole number, while the decimal after the decimal part is your decimal part, or you call it your fractional part. Is the decimal part or fractional part? Is the decimal or fractional part? Okay, so it is also important for us to be able to identify the parts. You remember that in whole number, we know that when we have a number something like 121448, this is our unit, this is our tenth, this is our hundred, this is our thousand, this is our tenth of thousand, and this is our hundred of thousand. But in the case of decimal numbers, let us see what it looks like. Something like 221.448. Okay, immediately after the decimal point, this place is called your tenth, or one decimal place, while the next four is your hundredth, or your hundredth or two decimal place, while the next one is your thousandth, or three decimal place, So how do we do the approximation? Let's take a quick example. Let's say you are asked to approximate to approximate 88.2678. So, so let's say to the first one, to nearest tenth, your B to nearest hundredth, the next one to your nearest thousandth, the next one significant figure, and the next one two significant figure. So let us see how to go about that. Let's go back to what our question looks like. Okay, we want to approximate 888.272678. Okay, let's go ahead. So we take it one after the other. 88. So to answer question here, 888.2678. We want to approximate it to the nearest tenth. So you start locating your tenth number. This is our tenth number. And like I mentioned in previous class, you check the number at the back. If the number at the back is 5 or more than 5, it will add 1 to the preceding number. So it will add 1 here. And every other thing here will vanish to 0. So our nearest tenth approximation will be, our final answer will be 888.26, 0.3.3. Then every other thing will vanish to 0.300. Don't forget, zeros at the back of a decimal point To a reasonable extent, they are highly insignificant, so you can otherwise write your answer 88.3. That is why nearest tenth is called one decimal place, because we can only see one number at the back of the decimal. Are we together? Okay, let's take the same question to answer nearest hundredth. Nearest hundredth. We want to approximate 888.2678 to the nearest hundredth. So you locate, this is our tenth. This is our tenth. This is our tenth, and this is our hundredth. So this is our tenth, and this is our hundredth. So that's where we are going to. So I'm going to the number at the back of my hundredth number is 7, and it is in the category of 5 upwards. So it will add 1 to this, it will add 1 to this, and all of this will vanish to 0. So definitely I'm going to have 888.2. 6 plus 1 will give us 7. So if you had the zeros at the back, it's all fine, and you can decide to just leave it as approximately 888.27. And that's why nearest tenth is also called, otherwise called, two decimal place, because we can only see two numbers at the back of the decimal. So let's quickly move on to the other one. The other one says nearest thousands. Nearest thousands. So the same question, 888.2678 to the nearest thousand. This is my tenth. This is my hundredth. And this is my thousands. So the number at the back of my thousandth number is 8 in the category of 5 upwards. So it's going to add 1 here. Those will vanish to 0. So finally, my answer is going to be approximately 888.2. Let's quickly have a look at what is happening up there. 8 adds 1. So I have 2, 6. 7 plus 1 is what? 8. You can put the 0, or you can decide to overlook the 0 because it's at the back of a decimal. So we have 888.268, and that's why nearest thousands is otherwise called 3 decimal place. Okay, let's answer the next question that says one significant figure. 888.2678 to one significant figure. One significant figure is the first number from the start here. So check the number at the back. It will approximate 1 because it is more than 5. So every other thing here will vanish to 0. So every other thing here will vanish to 0. And our final answer for one significant figure will be 8 plus 1, that's 9. 900.000. And you can also skip the 0.00 after the point. So that will be approximately 900. That's one significant figure. Okay, let's move to the second question to significant figure. So that will be Hans' question here. 888.2678. Two significant figures. So this is my 1SF. This is my 2SF. So check the number at the back. 8 on top of this 8, that's 1. Then every other thing will vanish to 0. It will vanish to 0. So my final answer will be approximately 8 plus 1, 9, 890.0000. And you can still leave it as approximately 890. And that is our 3 significant figure. But you cannot skip all these zeros when it is whole number. Don't forget, 9 million is not the same thing as 9. This is only applicable when you have decimal numbers. You can as well leave your answer like this or leave it like this. Okay, but you can write it like this to avoid confusion. I normally encourage students to write it like this so that they would not go and do that when they are doing whole numbers. Okay, so I'll give you some class work. Let's see how far you understand the question. So approximate 565 2196. 2196. Okay, approximate it to nearest tenth, nearest hundredths, one significant figure, and the next one two significant figure. See you some other time. Bye.